Welcome to a LeanStacks instructional video. This video is part of the Spring Data Fundamentals series. In this video, we build upon the Greeting Web Services project that we've been constructing as part of the Spring Boot Fundamentals series. We're going to introduce a data object design pattern for transactional entities. Transactional entities represent data which is created, modified, or deleted by system events. For example, a new user registration might create an account entity. Transactional entities share several common attributes: the primary key identifier, a reference identifier. This attribute may be used by external application systems to uniquely identify an entity. Often those systems may need to persist a reference to data within your application. Using a unique identifier which is not the primary key has a few benefits. If your organization changes the underlying database engine, perhaps the primary key identifier values may change during data migration. Also, if you use a long alphanumeric value as the reference identifier, it is more secure than using a sequential numeric primary key value. It's much more difficult for malicious parties to probe your system if it uses a GUID reference ID value to fetch data. The version attribute is used by the database to perform optimistic row locking and prevent data loss due to concurrent updates. The remaining four columns provide audit information. The created by and created at attributes indicate who created the entity and when. The updated by and updated at attributes indicate who last modified the entity and when. Let's get started. I've opened the project in the Spring Tool Suite. Go to the Source Main Resources Data HSQLDB directory and open the schema.sql file. Locate the Create Table statement for the account entity and update it to include the standard transactional entity columns that we've just discussed. After adding the columns, create a unique constraint on the reference ID column. This constraint ensures that duplicate rows cannot be created for this column, which acts as a secondary identifier for the entity. It also creates a database index for this column, making queries by the reference ID value perform much faster. Next, open the data.sql file. We need to update the insert statements to contain data for the new columns. I use an online GUID generator to create reference ID column values for data scripts. As you'll see in a moment, the application stores a GUID value in this column. Initialize the version column value to 0 and place a valid username value in the created by column. Use the Now database function to generate the current timestamp for the created at column and leave the updated by and updated at columns null. Repeat these steps for each inserted row of transactional data, ensuring that the reference ID values are unique. Now the database scripts are out of sync with the Java Entity Model classes. In the source main Java directory, locate the org example ws model package. In that package, create a new class named Transactional Entity, which implements the serializable interface. Annotate the class with the JPA annotation mapped Superclass. This instructs the JPA framework to map the attributes of this class directly to the table which backs the entity classes that inherit from this class or extend this class. In other words, all of the attributes of the transactional entity class will be directly mapped to the database tables of the classes which extend it. Declare the attributes for ID, reference ID, version, created by, created at, updated by, and updated at. Annotate the ID attribute with ID and generated, since it's the primary key for the transactional entity. Annotate the version attribute with the version annotation. The version attribute is used to perform optimistic locking for merge operations, for example, updating the row. Annotate the reference ID, created by, and created at columns with not null. These columns must always be populated to ensure data integrity. The version annotation ensures that the version attribute will always have a value. Initialize the reference ID attribute with a new random UUID value. Create the getter and setter methods for the attributes. Next, let's override the implementations for the equals and hashcode methods from the Java Lang object class. These methods are utilized by the set collection classes, which are often used to represent one-to-many or many-to-many relationships. For both the equals and hashcode methods, we will use the ID attribute to determine equality and to generate the hashcode value. Follow the rules described in the Java Lang object API documentation to implement the logic for these two methods. Now let's create methods to populate the audit attributes automatically during initial persistence and update operations. Create a method named beforePersist and annotate the method with the prePersist annotation. This tells the JPA framework to execute this method before an entity is persisted the first time. Within the method body, set the created@ attribute value to the current date. Next, let's create a method named beforeUpdate and annotate the method with the pre-update annotation. This tells the JPA framework to execute the method before an entity is updated. Within the method body, set the updated@ attribute value to the current date. In the beforePersist and beforeUpdate methods, we are easily able to set the audit timestamps. It would be really helpful to automatically set the value of the created by and updated by attributes as well. But how can we consistently and reliably know which user or process is performing the database operation? Introducing the Request Context class. In the org example WSUtil package, create a new class named Request Context. As its name implies, this class will act as a container for request-specific attribute values. Within the Request Context class, use the ThreadLocal class to create a container for usernames. The ThreadLocal class provides access to an attribute value which is specific and unique to the current thread of execution. Add static getter and setter methods to set and retrieve the username value for the current thread. Create an initialization method which sets all of the ThreadLocal attributes to null for the current thread of execution. As software engineers, we cannot control or guarantee how a J2EE web server will provision threads to the application. Therefore, we need to ensure that the request context is always initialized for each new web service request. Create a new package named org example WS Web Filter. Within that package, create a new class named Request Context Initialization Filter, which extends the Spring Framework's generic filter being class. Annotate the class with the component annotation so that Spring Boot's component scanner will detect the class upon application startup. Since the class is an implementation of a web filter, Spring Boot automatically adds the class to the filter chain. No configurations required. Override the doFilter method to invoke the initialization method on the request context. By initializing the request context before invoking the filter chain, we ensure that the request context is reset should this thread be reused. We need to populate the request context username attribute for the current thread. In the Spring Security Fundamentals video series, we created a class named Account Authentication Provider, which authenticates requests with a set of supplied credentials. Open the Account Authentication Provider class from the Security package. At the end of the Additional Authentication Checks method, set the username in the request context. This ensures that every request to the application which requires authentication will have the username added to the request context. In situations where the application has methods which do not require authentication, such as new user registration or password reset, you will need to ensure that the request context is populated. Another scenario which may require you to populate the request context is when new threads are spawned by the application. For example, when a messaging system or asynchronous process is utilized. The message handler receives the message in a new thread and therefore does not have access to the request context values from the message producing thread. Return to the transactional entity class. Update the beforePersist and beforeUpdate methods to set the value of the created by and updated by attributes respectively. Open the Account Entity Model class. Extend Transactional Entity. Since Transactional Entity now has the primary key ID attribute, remove the ID attribute from the Account class. Now that we have created the framework to support the transactional entity, let's see how easy it is to update the greeting entity to extend it. Open the greeting entity class. Extend transactional entity and remove the ID attribute. Next, update the schema and data SQL scripts to add the new columns. Let's run the application to see these changes in action. Open a terminal window and change directory to the project-based directory. Type mvn spring boot run and press enter to start the embedded Apache Tomcat web server on port 8080. I'm going to use the Postman RESTful Web Service client to test the changes to the application. First, let's fetch all of the greetings. Notice that the response JSON now contains the additional attributes from the transactional entity class. Next, I'm going to create a new greeting. The reference ID, version, created by, and created at attributes are populated with appropriate values. I'll fetch all greetings once again to show the new greeting within the collection. Finally, I'll update that new greeting. Notice that the updated by and updated at attributes are automatically populated. I'll fetch all greetings once again to show the updated greeting in the collection. Data modeling, and therefore entity modeling, is crucial to the success of an application. Establish data modeling standards and use JPA techniques, such as the mapped Superclass, to create a structured and reliable library of entity model objects. When creating database structures, carefully evaluate the data relationships and how the data will be queried so that you may create constraints that ensure data integrity and maximize performance. I hope you've enjoyed this video. Subscribe to the LeanStacks YouTube channel and follow the LeanStacks Google Plus page to receive updates as new videos are published. As always, you can find more information on LeanStacks.com. To view the complete repository illustrated in this video, see the GitHub repository URL in this video's description.